Welcome back, guys. I'll be running through another example of equilibrium and free body diagrams, but before I do the second example, I would like to tell you on how to convert a uniformly distributed load into a concentrated point load. So let's assume we have a uniformly distributed load of 2 kilonewtons per meter that spans over a length of 6 meters. Very nice and simple. We just multiply the force, the UDL, by its length. So we have 2 kilonewtons per meter times 6 meters. This gives 12 kilonewtons. That is the concentrated point load, and the concentrated point load looks something like this. Obviously it's going to be in the middle of the UDL, and this becomes the 12 kilonewtons. Nice and simple, so we just multiply the uniformly distributed load by its length. Next, we have this example here. We have a simply supported beam with a UDL and a positive clockwise moment at the end. The span between the supports is 4 meters, and the extensions on both sides are both 2 meters. Now, how would we start this? By equilibrium, as mentioned before. So we have sigma fx equals 0. Sorry, before I do this, we have to show the vertical and horizontal restraints. So we have a pin here. We have VA, and then we also have a horizontal restraint, HA, and we have a vertical restraint here at the roller, VV. I'll call this point A, and I'll call this point above this support B. As we said, sum of the moments in the sum of the forces in the x direction equals 0. Observing this diagram, HA is the only horizontal force, so immediately HA equals to 0 kilonewtons. Next we have sum of the forces in the y direction, so sigma Fy is equal to 0. So notice that we have VA and VB, so we do VA plus VB. Now we have a downwards uniformly distributed load, so minus 2. So we have to convert the UDL into a concentrated load, so 2 times 6. We multiply by its span like I previously mentioned, so the span is from here to here. 4 plus 2 is 6, so minus 2, which is the UDL, times 6, which is its span. So now it becomes a concentrated point load equals 0. This means that VA plus VB equals 12. Next we do the sum of the moments about point A equals to 0. So sigma MA equals to 0. First of all, on the left edge we have a we have a negative clockwise moment. So minus 20. And remember that we're doing the sum of the moments about A. So HA and VA obviously have no moment about point A, since there is a lever arm which equals 0, so no lever arm. And then we have a VB. This VB produces an anti-clockwise moment about this support here. So like I previously mentioned, I place my finger and I move in the direction of the force. So if I push my paper, it's going to move anti-clockwise. Immediately we know that it's an anti-clockwise moment, so it's plus 4 plus VV times the perpendicular distance to this point, which is 4. Now we have to do the moment of the UDL about the support. Obviously the UDL causes a clockwise moment about the support, so it's minus 2 times 6. Again, I'm converting it into a point load up to this stage. Over here, this becomes a point load of 12 kilonewtons. Now since this force is 12 here, and we're doing this moment, this distance from here to the support is 3 meters. So the moment caused by BL by the concentrated load which was created from the UDL. The perpendicular distance is 3. So minus 2 times 6 times 3 equals 0. Solving for this, we get VB equals 56 kilonewtons. As we previously mentioned, right here, VA plus VB is 12. Substituting VB as 56 kilonewtons, we have VA plus 56 equals 12. This gives us VA equals minus 44 kilonewtons. So finally we just established our solution. We found that VA equals minus 44 kilonewtons, VB equals 56 kilonewtons, and finally HA equals 0 kilonewtons, as it was the only horizontal force. So just a quick recap of this example. Sum of the forces in the x direction was 0. Since HA is the only horizontal force, HA is 0 immediately. Next we did the sum of the vertical forces, Fy equals 0. So VA plus VB, so the vertical restraints, minus the UDL, which is 2, and we multiplied by 6 to convert it into a point load, since we can't add kilonewtons with kilonewton per meter, you know. This gave a VA plus VB equal to 12. Next we did the sum of the moments about point A equals 0, so it was minus 20, as it's a clockwise moment, plus 4 times VB, minus the UDL, the moment caused by the UDL, so 2 times 6, which makes it a concentrated point load of 12, multiplied by the lever arm, which is 3, times 3 equals to 0. This gave us VB of 56, and from there we were able to find VA and establish our final solution. Okay guys, that's the end of this example. Thank you very much for listening.